am Dr. Kalaivani from the Department of Public Health Dentistry, and today we are seeing about sampling techniques. So sampling technique is one of the methodology which is used in research, and today we will be seeing about what are the different methods of sampling. Like first of all, we'll be seeing like what is sampling and why it is required, and what are the advantages of sampling, and what are the requirements to do sampling, and the methods of sampling, and sample size calculation, and finally errors in sampling. So first, coming to what is sampling. Sampling is a process of selecting a sample of appropriate and manageable or adequate size for the study. So why sampling is required? Because we can't take all the population in the universe to do a study. But at the same time, we can take certain people who are truly representative of the study population, and we can do a study in that particular sample, and we can produce the results or generate the results to the whole of the study population. So for that only sampling is required. So the next is the sampling frame. So it mainly contains total of the elements of survey population which is redefined according to certain specifications. And the sampling units includes the individual entities which forms the prime focus for sampling. So next, coming to sample. So we can see here we have the total population, but we can't take all the population. But still we can take a sample which is representative of the particular population. So here we can see sample is a part of sampling frame, which in turn is part of the universe or the reference or the parent population. So this sample should be representative of the universe or the parent population which we are going to study. The advantages of sampling are it mainly reduces the cost, time, and also personnel involved, and we can do thorough investigations of the units of observation, and we can gain adequate and in-depth coverage of the sample units. The ideal requirements of sampling includes efficiency, that is the ability of the sample to yield the desired information. Next is the representativeness, that is a sample should be representative of the parent population so that the inferences which are drawn from the sample can be generalized to that population with measurable precision and confidentiality. Next is the measurability, that means it should have valid estimates of its variability can be made. Next is the size. The sample should have a size which is large enough to minimize the sample variability and to allow the estimates of the population characteristics made with measurable precision. Next is the coverage. So it should have adequate coverage to remain representative of the study population. Next is the goal orientation, because the sample size should be oriented towards the study objectives and research design. And the feasibility is also one of the important requirements, because the design of the study should have the sample enough to be carried out in practice, and the sample should be in such a way that it should yield the desired information with appreciable savings in time and cost. In other words, it should be cost efficient and also should utilize only less time and economy. So the next we are going to see about sample selection. So first we have seen what is sampling and how a sample is the representative of the population, and next what are the advantages of sampling and what are the ideal requirements of sampling. So now we will be seeing about how to select a sample. So there are two methods of sample selection, namely purposive selection and also random selection. The purposive selection mainly aims at representing the population as a whole, and we can deliberately or purposively select only the individuals who seem to represent the population under study. But in random sample, the sample of units is selected in such a way that all the characteristics of the population are reflected in the sample, and that is we are randomly selecting the samples. So that is random selection Purposive selection means we are deliberately or purposively selecting the individuals who we think that they represent the population. So the main advantage of purposive selection is it is easy to carry out and it does not need the preparation of sampling frame. But the main disadvantage is it can substantially underrepresent the rates of the population under study. For example, when we are finding about the status of oral hygiene or oral hygiene practices in an urban school, the 30 representative students may be picked, examined and assessed for oral hygiene. So this is one of the example for purposive selection. For random selection, we should select the sample in a random manner. That is, each and every individual in the particular population has an equal chance of appearing as a random sample. So for example, anyone can be included in the same survey. The first type of purposive selection, we are handpicking the students who we think that they are the representative to study the oral hygiene practices. But in random selection, we'll be selecting any student randomly and we will be assessing the oral hygiene practices. So these are the two methods of sample selection. So next, coming to the sampling methods. Sampling methods is mainly divided into non-probability sampling and probability sampling, and it also includes other sampling methods like multi-phase sampling and multi-stage sampling. So first, coming to the non-probability type of sampling, it mainly includes three types: quota sampling, purposive sampling and convenience sampling. So the next is the probability sampling, that means the random selection. So it includes simple random sampling, systematic sampling and stratified sampling. The stratified sampling is again divided into stratified random sampling and stratified systematic sampling, and finally the cluster sampling. So these are all the different sampling methods. So the non-probability sampling, it mainly includes the purposive selection of samples, and probability sampling includes random selection of samples. First, coming to the non-probability sampling, they are not truly representative and they are less desirable than probability samples. But when this is used, so the non-probability sampling can be used where a researcher may not be able to obtain a random or stratified sample, or sometimes the study may be too expensive if we carry out random sampling, and sometimes it is not necessary to generalize to a larger population. So in those times, we can do non-probability sampling. So the first type of non-probability sampling is quota sampling. So the quota sampling means we'll be selecting the quota before the start of the study. That is, mainly the general composition of sample is decided in sample in advance, and the right number of people we somehow found to fill these quotas, and it also mainly includes a particular segment of population. So for example, in Tamil Nadu, we can see that the majority of people is speaking Tamil as a native language, but there are other language population also. So if we are conducting a study about perception among people in Tamil Nadu about banning hookah products, then we should include both the Tamil speaking people as well as the other language speaking people also. For example, if we consider that there are around 90% Tamil speaking people and 10% other language speaking people, means then we should also include both the Tamil speaking people as well as other language speaking people also. So in this time, the sample will no longer be representative of actual population, because we are creating a quota for the other language population also, and we'll be telling this much percentage of the sample should have the other language speaking people also. So at this time, we can tell that we can't do a random selection, but we are purposively selecting other language population also. So that is an important significance of quota sampling. That means we'll be deciding who we should have in advance of the study, and we will include the same. So this comes under non-probability sampling, quota sampling. So the next is the purposive sampling. So it is also a type of non-probability sampling where it is a non-representative subset of some larger population and it serves very specific need or purpose. For example, certain groups will not be very known or the access will be difficult and will be interviewing whoever is available. So at that time, we'll be doing a purposive sampling. And another subset is snowball sampling. That means mostly the hidden population. For example, the sex trafficking or any drug dealers, so they will not be available in the general population and we can also not generalize them to a larger population. So at that time, what we'll be doing is we'll be handpicking 1 or 2 person and from the 1 or 2 person, we'll be selecting some other person. So likewise, as the snowball rolls, the number of samples will also be increasing. So that's how we'll be doing a snowball sampling, which is a part of non-probability sampling. Then finally, we can see convenience sampling. So this is one of the easiest sampling technique, which is not probability, and we'll be taking whomever we are getting. It also includes the accidental sampling, and here we are not taking any random selection, and only the volunteers who are willing to participate in the study will be selected. So for example, if we are conducting a study among school children, we'll just see like who are all present at that particular day, and if we do a study, then it is a convenience sampling because we are doing at the convenience of ourselves and we are not taking any sampling frame or we are not doing any random selection. We are just asking the volunteers who are willing to participate in the study and who are all present in the study. So that is a type of convenience sampling. So now to summarize, quota sampling means, for example, we have a larger population and we are giving a quota like male who are above 50 years. So these people will be included in the study. So this is a type of quota sample. So next is the purposive sample. So here we are handpicking like who we should select in the final study. So this is a type of purposive sample. So next is the snowball sample. So first we'll be doing in a hidden population. So first we'll be selecting the person whom we want to study and we will be identifying the other 2 persons from the initial or the first sample, and these people will again identify other people. So as the snowball increases, this sample size also increases and it is one of the non-probability type of sample. And the final is a convenience sample, so which we are selecting according to our convenience. Maybe the volunteers will be selected in convenience sample. So next is the probability sampling. So first we have seen about non-probability sampling and now we will be seeing about the probability sampling. That means random selection of sampling units. So here it is the most recommended method and all the sampling units have the same probability of being selected and included in the study. And here generalization of results to the whole population can be made. The first type is simple random sampling, which tells that each and every unit in the population has an equal chance of being included in the study. The selection of unit is determined by chance only. So the basic procedure is to prepare a sampling frame to decide on the size of the sample and to select the required number of units, which can be selected using lottery method or table of random numbers. So the next type is systematic sampling. So systematic means we'll be selecting with the random and then every kth element is selected until the appropriate size is achieved. That means, for example, we'll be selecting a particular roll number. For example, if you are telling 5, then we'll be having the same interval between the other samples. So if you are telling like every 10th person should be selected, then our first number is 5. So next every 10th means 5, then 15, then 25, then 35 and so on. So likewise, if we are selecting systematically, then it is systematic sample. So for example, if the population size is capital N and the sample size or the desired sampling is small n, then the sampling interval will be n divided by small n. That means the population size divided by our desired sample size. So the number which we get will become the. So the next type is stratified sampling method. Here the population is subdivided into groups known as strata. That is, we are artificially creating the groups which are known as strata based on common characteristics. So we will be doing two types of sampling, namely random sampling as well as systematic sampling in the stratified sampling method. So the first is the random sampling method in stratified sampling. That means stratified random sampling. So it mainly includes the population to be sampled, that is strata, which is homogeneous in nature. So within the strata, all the sampling units will be homogeneous. For example, if we want to find out about DMFT among different age groups, and we have divided it to two strata, that is 24 to 35 years and 64 to 75 years. So the 24 to 35 years is one stratum, and 64 to 75 years is other stratum. So within the stratum, the sampling units will be homogeneous. So a simple random sample is then chosen from each stratum. But the population is heterogeneous because 24 to 35 is different from 64 to 75. So this population is heterogeneous with regard to the characteristic under study. The main advantage of this sampling is it has more representativeness and greater accuracy and covers a wider geographical area. But the main limitation is we should be careful in dividing the population into strata. The next type of sampling is stratified systematic sampling. So this is similar to the stratified random sampling. The only thing is we will be systematically deciding the sampling units. For example, the every kth element. If we are telling every 5th person or every 10th person should be selected, then we will be first starting with a random number. For example, if we are telling 3. So next, every 5th member means 3 plus 5, which is 8, and then 5. Again, 8 plus 5 is 13, and so on. So likewise, we'll be selecting the sample. So this is the stratified systematic sampling. It has an advantage that it eliminates sampling variation. The final method is cluster sampling. So in the previous method, we are dividing strata, that is artificial groups. But in cluster sampling, the population itself forms natural groups or clusters, such as villages, wards, blocks, or children of a school, etc. And here we'll be doing simple random sampling among the groups or clusters of individuals. Here the sampling units are not individuals, they are the clusters, and the sampling frame is the list of these clusters. And then all the units in the clusters are surveyed. The main advantage is that it is administratively simple and less expensive, but the disadvantage is it cannot be generalized. So again, we are summarizing. Simple random sampling is each and everyone has the equal opportunity to be included in a sample. So that is simple random sample. Next is the systematic sample. So the first unit will be selected according to us, and then every kth element will be selected. So that is the systematic sampling method. Next is the stratified sample. So here we are dividing the population into stratum, and then we are either randomly or systematically selecting the sample. So that is the type of stratified sampling method. The final is cluster sample. So here the population is already naturally divided into clusters, and all the units in the cluster will be selected. So this is an example of cluster sampling. So now we have seen about probability and non-probability sampling methods. The other sampling methods are multi-phase sampling and multi-stage sampling. The first is multi-phase sampling. So the main thing which we want to understand is multi-phase sampling means we'll be selecting a population, and from the population we'll be selecting the subsample. So as the step progresses, the final sample will be very lesser when compared to the first sample. So this is the basic idea of multi-phase sampling. So here we'll be collecting part of information from the whole sample and another part from the subsample. And if we have any specific disease to be detected, or we want to find the prevalence of any particular disease, then this method can be adopted. So for example, we want to find out treatment needs among children in a school. So first we'll be examining all the children in the school. Then only those with the oral health problems will be selected in the next stage. Next, only the treatment who are needing any treatment, only they will be selected. And finally, the number of children in the subsamples in the third and fourth phase becomes smaller and smaller. So we can see that it is like an inverted triangle. So first we can see the sample is huge, but it is again concised into those with oral health problems and then those who are needing only the treatment. So we can see that as the phase continues, the sample size or the number also decreases. So this is an example of multi-phase sampling. So the next is the multi-stage sampling. So this is mainly followed for a nationwide sampling, and here the groups or clusters will be selected and subsamples are required to obtain the desired sample size. So first, for example, if we are doing a nationwide study, then we'll be selecting states within the countries, and then we'll be selecting towns within each state, and then the neighborhood within each town. So as it is like each step will be going. So to simplify, we can see like we want to conduct a nationwide study in India. So first we'll be selecting certain states which are representative of the particular region. Then we'll be selecting one particular state, and in each particular state we'll be selecting certain districts, and in each district we'll be selecting certain towns, and in each town we'll be selecting certain villages, and in each village we'll be selecting the certain neighborhood. So this is the example of multi-stage sampling. So this is different from multi-phase sampling. So these are the other sampling methods. So till now we have seen about what is sampling, what are the advantages of doing sampling, and what are the ideal requirements of sampling, and what are the methods of selection for sampling, and the methods, that is non-probability sampling as well as probability sampling, and finally the other sampling methods including multi-stage sampling and multi-phase sampling. So till now we have seen about what is sample, but how we can select a sample, like what is sampling size, like, and why it is required, because the main idea of sample is that it should represent the population, but if the sample size is not adequate, then it will not be representative of the population. And also we can tell that as the sample size increases, the precision also increases, and the sample size is mainly calculated based on the estimate of the characteristics using any pilot study or previous studies. And then we can also use sometimes the knowledge or desired precision or the availability of experimental material and practical considerations. So these play a major role in determining the sample size. And sample size can be determined based on the type of the study or the data. For example, if you are doing any continuous data or any dichotomous data, like based on the nature of the data, we can calculate sample size. So if we are conducting means, then the sample size is different, and if we are involving any proportion, then again the sample size calculation will be different. And we can also compare different means in terms of intervention studies, or we can also compare to proportions. So before going to the other subject, I just want to tell you here the Z is constant. That means that is 1.96, which is approximately 2. And then we can tell like we should select the sample without any error. That means the sample we selected should not do or cause any error to the study results. So with keeping in that mind, we'll be seeing and we'll be like trying to avoid any type 1 error or type 2 error. So we'll be considering the standard deviation or the sigma, and also the margin of error, and also to avoid, and the power of the study also should be considered so as to avoid any errors. So all these factors play an important role in sample size calculation. So now coming to the errors in sampling. The sampling errors can arise due to the sampling process, faulty sample design, or the small size of the sample. And sometimes it can also arise due to non-sampling errors, mainly the coverage error, that means the non-response or non-cooperation of the informant, or the observational error due to the error on the interviewer side, that means due to interviewer's bias or imperfect techniques, or both, or sometimes processing error which arise due to errors in data entry or recording of responses. So all these play an important role in creating error, and all these errors should be avoided while doing sampling. So till now we have seen about the basics of sampling, and how to calculate a sample, and also the sampling errors. So these are my references, and thank you.